Look at this first problem. Finding a power 2005. It is not that easy. So then how do you find without finding a power 2005? How do you find determinant of this? We have property that of AB is det A into det B. So based on that, here you can write det of A power 2005 minus 6A power 2004. You can write it as by taking 2004 common, A minus 6I. It is one matrix, this is other matrix. You can write it as det of A power 2004 into det of A minus 6I. Here it is det of AB, same property. In place of B, you write A, which is det of A square. You can write det A into det A, which is det A whole square. So based on this det of A square, you got det A whole square. On the same logic, it is det A power 2004 into det of A minus 6I. Here matrix A is given, that is 24 minus 22, which is 2. From that I can write here it is 2 power 2004 A minus 6I. Here A minus 6I will be 611224 minus 6006. You get here it is 0 minus 11, 2 minus 2. This is the A minus 6I. Its determinant will be 0 minus how much? Minus of 22. You get 22 into 2 power 2004 or 2 in 2 power 2005 into 11. Right. Here it is plus 11. So you get here minus 11. This option is correct. Here second question, 3 by 3 matrix, then that A will be divisible by. So in this, whatever number you consider it, all here it is 9, 25. These are all, if you divide this with 8, remainder is 1. 8 3 is 24, remainder is 1. It is of the form 8n plus 1, where n starts from 0, so on. So now, if you consider this matrix A with He didn't say that particularly nine elements. He told, let us take any format, doesn't matter. If I apply C2 is replaced by C2 minus C1, uh, one element is of the form A10 plus 1, other element you can write A10 plus 1. Difference will be a multiple of A. Similarly, C3 is replaced by C3 minus C2. There, that also you get multiple 25 minus 9, 16. So like that, uh, these two columns will be multiple of 8 and 8. Hence, it is multiple of 64. There are two columns which are 8 multiples, like this, whatever it may be. Here, 8 multiples are there. Here, 8 multiples are there. You take 8 common from the second column, 8 common from the third column. It is definitely 64, whose determinant will be 64 multiple, which is divisible by 64. Now, these are all based on properties. He given one condition here, AB whole power 10. He given like this. If you consider this AB power 10, it generally can we write it as A power 10, B power 10 means answer is no. Why like that? Suppose AB whole square is there. Basic definition is only AB into AB. So this is matrices. Matrices, which properties they satisfy? Matrices satisfy additive property and associative with respect to multiplication as well as addition. Is matrices may not commute. That means you take two matrices here, A and B. Uh, Take example A as 1, 2, 3, 4, B as 4, 5, 6, 7. No need to have all entries. First entry, if you find out 1 into 4 plus 2 into 6, you get 22 some elements. If you take BA, that is 4 into 1, 4 plus 5 into 3, 15, 19. So obviously one entry is not same. This is called commutative property. Matrices need not commute each other. So even if I apply associative property here, it's like by using this property, I can write here it as AB of C as A of BC. That in the sense C here is AB. Again, applying associative property, I can write BA of B. So here it is again, if I apply associative property, A of BA into B, which is AB of A into B. or I can write AB of AB, A square B square. So this condition will be satisfied once they given a condition that they commute each other. But he is not given any condition like they commute each other, they given some other condition. So it's for a number system, AB or real numbers, you can write like this. But matrices, you should not write. Then how do we proceed? Is all procedure is based on the condition. First, let us take AB whole square. This is when I only told you here. So AB power n need not be A power n. So this result I proved only when AB whole square is A square B square possible when AB equal to BA. This is no way connected with the problem. Why I given such an example for you is you cannot apply number rules for matrices. So let us see how we have to proceed. This one is AB of AB, which you get associative property. It is like AB of C. So A of BC, in the sense A of B of AB. So here it is A of BA of B. So now in place of B, what I do here is, it is like in this place, given condition BA he given as A square B in the book, that question. This I can write it as A cube into applying associative properties. So this is what AB whole square. AB whole cube, I can write it as AB whole square into AB, which is A cube B square of AB. But still, what form we get, we don't know. Let us further simplify it. A cube B of BA of B, this part, associative property. You can write BA as in a based on given question A square B of B. So this you can write A cube A square B square. Same associative properties. Here still I want A power K format. So this B also I have to move it to the right side. Then I can write A cube BA of A into B square. This BA, I can write it as A square B from the given condition. Again BA B square, which is A power 5. Again BA, I will write it as A square B into B square. I get here it as A power 7 B cube. So here it is AB whole square. We got it as A cube B square. AB whole cube, I got it as A power 7 B cube. So AB whole power n I can write uh, A power 2n 2 power n minus 1 into B power n. Let us check. Square is there 2 square 4 minus 1 A3 B square. AB whole cube 2 cube 8 minus 1 7, such a sequence. Now he is asking us AB power 10. So here it is a 2 power 10 minus 1 uh, into b power 10. So answer is 2 power 10 minus 1. That is answer will be finally 2 power 10 minus 1. That is 1023. So here this first problem is based on property. Second problem is based on property. Now look at the third problem. In this third problem, actually, how do you find A? There are two ways. One is you assume A, B, C, D, E, F, G, H, I multiplied and multiplying first row with first column, then equate with 3 minus 1, 5. Then you will have an equation. Solving those, you get 9 variables, which is very lengthy. The second procedure is this whole matrix, if you take it as X, this other matrix, you take it as B. From here, how do you find the A value means? So finding multiplying with it inverse, like 2 into 2 inverse is 1, A into A inverse will be identity. From here I get A into identity is this. From here I get A as Bx inverse. So that means for this matrix you have to find inverse and then multiply, we get the required. This is another idea of solving the same problem. But so every elementary row operation has denoted with one matrix. So if you carefully observe this arrangement of the matrix, here you have a second row becomes first row becomes the second row. That means R2 is interchanged by R1. So actually here you in the place of A, because these elements are not changed, 0 1 0 0 0 1, you take identity matrix 1 3 4 3 minus 1 5 minus 2 4 minus 3. Once you multiply any matrix by identity, you get the same matrix. But this here uh, second row becomes first row. Then just interchange the rows 0 1 0 1 0 0. Keeping this as it is. Now look at this. Now you can observe, you get here it is 0 into 1, 0 1 into 3. You get the second row on the top, first row in this. So two rows I got it, and the third row, to get third row, just you multiply this with this as it is. This you change it to I want minus 2, right? Third row you multiply with make it 0 0 minus 2. Then obviously you get this. Right. What you want is here 4 minus 8 6, right? That means you multiply it by 2. This first two rows elements will be same. Then here you have 4 minus 8 6, which is the required matrix here. But with a simple reason, finally, without finding determinant, without forming any equations, by just elementary operations related, This will give you, this is the required matrix with what you have to right. Now, uh, if you look fifth question, you have first you should be acquainted to the types of matrices. When data A is not zero, we say A is non-singular. When data A is zero, we say A is singular. So now you understood this. First of all, to answer the question, uh, you should be familiar with the terms, terminology. Orthogonal matrix means A into A transpose is identity. We say A is orthogonal. Idempotent means A square is A. We say A is idempotent. Now, what kind of matrix it is? If you carefully observe, here A plus B plus CD, here AB plus CD. So whenever symmetric matrix means A transpose is A, given matrix can be written as product of two matrices. Now I am trying here how to split into two matrices. After that, you can find determinant, which easily you can get. Let us say this I already named it as A. Mm, if I write 100, all right. I want one here. I'll make it 0, 1, 1. So 0, 1 plus 1, 2 I get. Here I'll make it to 0. I'll write A plus B, C plus D. 0, 1 into A plus B. This one, it is 1. 1 into C plus D, I get the second element. I get here 0, A, B, C, D. 0 into AB, sorry, 0, 1 into AB, CD. So now uh, to get this part, I'll write here 0, A plus B, C plus D. Then 0, A plus B, C plus D. Yes, I got this. But here A plus B whole square we are getting. I will interchange it to C plus D, A plus B. 0, C plus D, A plus B. I got this element. C plus D into A plus B, A plus B into C plus D. 2 times I get C plus D into AB, A plus B into CD. Here also I can write AB into C plus D. I want if I write AB here, CD here, CD into A plus B, AB into C plus D, ABCD, ABCD. So this is a symmetric matrix which can be written as product of two matrices, right? So now I can write answer as 0. because one row is zero, determinant value 0. So then it is a singular matrix. Till now, 5 problems I discussed. All, if you observe, all are based on the properties. Whenever they ask any exam, any competitive exam, this also I can make it as a property here. Det of a power n as det a whole power n. This is the property I used. And here also, what properties? What I did is column operations. So take, if you do like this, there is no change in the value of determinant. What we found out is each row is multiple. Here we used these properties. Which property? Associative property and commutative properties. And the how to change, how to use condition in getting the required result. Here we used elementary transformations. Elementary transformation means R2 is replaced by R2 minus R1, R2, R2 interchanged, or multiplying row by some number. How it converts matrix. Here I used all the definitions given here of how many kinds of matrices we have, and symmetric matrix advantages. I then based on that I am able to derive that it is a singular matrix. So here it is number of orthogonal matrices I already defined here. What is orthogonal matrix? A into A transpose is identity. So he said 2 by 2 particularly. A, B, C, D is a given matrix. Transpose, if you take first row changes to first column, identity means 1, 0, 0, 1. From here, A square plus B square, CA plus BD, C square plus D square. 1, 0, 0, 1, he told entries are 0. Comparing elements in the same places. Possibility for sum of squares is 1. A is 1, B 0, or A 0, B 1. Here C 0, D 1, or C 1, D 0. This is possibility. So based on this, at the same time, AC plus BD also 0. CA plus BD also must be 0. Suppose if I take this option A as 1, B as 0, then C0 D1. Suppose if I take like this, C0, which option I am taking here to construct this? I am taking A1 B0, then AC uh, here C0 D1. Then AC becomes 0. This is possible. If I take A as 0, B as 1, C as 1, D as 0, are they satisfying the condition? A C 0, B D 0. Yes. It is one matrix, it is second matrix. Now another possibility A1 B0 C1 D0. But you construct this matrix here AC plus BD, you are getting 1 plus 0, which is contradiction. We have to get AC plus BD also 0. So final answer is there are two such matrices. So not many, there are two matrices with 0, 1 as entries which are orthogonal. Then here this matrix addition ABCD plus EFGH, we can add matrices. It is called addition of matrices, which is, but if you consider this addition of determinants, if you write ABCD plus EFGH, you can find evaluate by evaluating individual determinants. But like matrix addition, determinant addition is not possible. So this determinant addition is possible. Here it is AC ABCD plus ACGH is there. Then keeping one column identical column as it is, don't add A plus A. You can add second column. You can check it what I told correct or not. 1, 2, 3, 4 plus 1, 3, 4, 5 if you take 1, 3, 2 plus 4, 6, 9. You can check 4 minus 6, 5 minus 12. Here it is 9 minus 18. See. So this is very careful. Good property based on this. Many sums can be solved. So this given equation, I can write it as keeping which is common here. Second and third columns are common? No. I think first and second rows are common, right? So then I can write this given equation as keeping identical rows common. X1, Y1, 1. I can add third row, X2 plus X3, Y2 plus Y3, 1, which is 0. So what it says, determinant to 0, what it indicates geometrically, these points are collinear. So this here x1, y1, here is x comma y, here is x2 plus x3, comma y2 plus y.
Sir,
Yes,
sir, in the third row, third element will be 2.
third row, third element. No. Ah, yes, thank you. So here what it says, determinant, what it says is uh, this equation represents a line, collinear points. X comma y is 1 point, x1, y1 is 1 point, x2 plus x3 y2. So this geometrical meaning of this equation is it is a line which passing. So now what he said, is it altitude? Is it median? Is it angular bisector is the question. So here it is what it represent means it definitely represent equation. Which equation? Here you have x2 y2, x3 y3. Here you have x1 comma y1. Here is a midpoint, x2 plus x3 by 2, y2 plus y3 by 2. So this is now if you carefully look into this, this is x1 y1 x2 plus x3 by 2 y2 plus y3 by 2 is a median equation. So this one more step I can write. Here x1 y1 1 x2 plus x3 by 2 y2 plus y3 by 2. Here you should maintain 1. Then only that line passing through the specified points. So it is a median. In this you should know I use two properties. One is addition of determinants. Other is determinant generally if you remember it in vectors are coplanar or collinear. You can use that is 0 or that is 0 here. With this we say that it is a line passing through the specified. So line passing through the point and midpoint of other two side is definitely a median which passes through it.